Hi everyone and welcome back. In our previous lesson we learned that for one revolution all our trigonometric functions have two angles that makes their ratios true. Now we want to learn how to calculate that second angle for any example that is given to us, and therefore we introduce the reference angle. Now let's go and look at an example. Now again we are given the cosine of theta is equal to a half. Then we work out theta and we follow the same steps as our previous lesson. So theta is equal to the cosine to the power of -1, which is the inverse of the cosine, and we put the ratio in brackets. Now listen very carefully to this. Once we take the cosine over as its inverse and we work out this right side, we end up with the reference angle. That means that this angle originally must be equal to 60 degrees. Now in this example it's quite easy because theta is the only value that is in this angle, okay? So theta is equal to the reference angle, which is 60, and therefore it's also easy to calculate the other angle. All that we do is we know that the cosine of theta has a positive ratio. It's positive in quadrant 1. We already worked out that angle. And now we have to work out the angle in quadrant 4 between 270 and 360. So all that we do is we take this critical point and we minus the reference angle. So 360 minus 60 gives us 300 degrees. And therefore our other angle for theta is 300 degrees. Okay, now what about the following example? We are given the cosine of theta plus 30 degrees, and that is equal to a half. Now what we need to do next is we need to work out or move this cosine as its inverse, right? So theta plus 30 degrees is equal to cosine to the power of -1, and we put the ratio in brackets. Now again, once we work out this right side after we move the function as its inverse, we are given a angle. Now this angle is called our reference angle. That means that this original angle must be equal to 60 degrees. This is our reference. Now as soon as we work out this reference angle, then I'm going to underline it, as you can see. Now this is where the steps change, because now we want to go and see in which two quadrants we are working. So the cosine of its angle is a positive ratio. We are working in quadrant 1 as well as in quadrant 4. So what I do first is I'm going to write quadrant 1, and then I'm just going to take this theta plus 30 and I'm going to equate it to the reference angle, and I'm going to work out theta, and we get 30 degrees. There we go. Now the next quadrant is quadrant 4, and here is a small little change, because remember when we worked up here, this was our reference angle and we said 360 minus our reference angle. Because theta was the only angle originally, well, we know that the answer was 300. But look here, we have to go and take this reference angle and subtract it from 360. So we have to do that first. So we write theta plus 30 degrees is equal to 360, okay, minus the reference angle, which is 60. And after we do this, we work out theta. So this plus 30 goes to the other side, becomes a minus, and theta is equal to 270. And we can do the substitution of these. So 270 goes in there, plus 30, it's 300, and the cosine of 300 is a half. What about if theta was 30? 30 plus 30 degrees is 60 degrees, and the cosine of 60 is equal to a half. I hope you could follow, and let's go and look at one more example. Now in the following example, there are a couple of finer points that you have to pay attention to. We are given the sine of 2 theta minus 20 degrees is equal to 0,678. Well, we follow our steps normally to calculate theta. So at first we are going to take the sine to the other side as its inverse, and 2 theta minus 20 degrees is equal to sine to the power of -1 and the ratio in brackets. Once we calculate this right side and we end up with the angle, that angle is our reference angle. We end up with 2 theta minus 20 degrees is equal to this reference angle. Now it's very important to understand that this original angle has to be equal to this reference angle for this to be true. So this is our reference angle, and I'm going to underline it, and after I do that I'm going to figure out in which two quadrants we are working. So sine of its angle has a positive ratio, so we're working in quadrant 1 and in quadrant 2. So I'm going to start with quadrant 1 and we just solve for theta normally. So 2 theta minus 20 degrees is equal to 42,68755,299 degrees. Do not round this off at all, because we can only round off our final answers. That's a very important thing to remember. So now we take this minus 20 to the other side, and 2 theta is equal to 62,68755,299 degrees, and then we divide with the coefficient, and then we have theta is equal to 31,34 degrees, and this one I rounded off to 2 decimals. So there we go. Now the second quadrant we are working in is quadrant 2. So I write down quadrant 2, and now you have to remember this part. To work in quadrant 2, we work with this critical point minus the reference angle. So this is our reference angle. So we're going to say 2 theta minus 20 degrees is equal to 180 degrees minus our reference angle. And then we solve for theta normally. So this minus 20 goes to the other side, becomes plus 20. And once we do all of this, we see that 2 theta is equal to 157,312,447 degrees. Then we divide with this coefficient, and theta is equal to 78,66 degrees. Now we can go and test our answers. If we take this 78,66 degrees and put it in the place of theta, you will see that this angle that you calculate will be between 90 and 180. And if we do this entire sum, we will see that it ends up with that ratio. Now we can also test the 31,34. If we put that in the place of theta and we calculate this angle, you will see that it will give us an angle between 0 and 90. And if we do the entire sum, it will also give us this ratio. Well done, and hope you could follow nicely, and see you again next time. Bye.